All right, let's talk about one of the biggest, most expensive problems in all of crypto. How do you get different blockchains to actually talk to each other without losing billions of dollars in the process? Because the solution to this might just change everything. And I'm not exaggerating. That number is real. Over $2 billion gone. Stolen from the very tools that were built to connect this whole ecosystem. So the question is, why does this keep happening? And more importantly, how do we fix it? Let's dive in. Okay, so to really get why bridging is so incredibly risky, you have to start with the core problem. The best way to think about it is to picture the entire blockchain world as this huge ocean, just dotted with isolated islands. Right. Every single blockchain is its own little sovereign nation. It's got its own laws, its own currency, its own language. Now, this isolation is actually a good thing for security. It's a feature, not a bug. If one island gets hit by a tidal wave, the others are totally fine. But it also creates this massive barrier. How do you trade or communicate between these islands? Think about it like this. Island Ethereum literally cannot see what's going on over on Island Solana. It can't read its books. It can't verify its history. They're speaking completely different languages. Solidity, Rust, ClojureScript. So if you want to move your money from one to the other, you're going to need a bridge.
Now, here's the crazy part. Your tokens never actually move from one island to another. It's more of a clever trick called lock and mint. First, you take your real asset, let's say some ETH, and you lock it up in a smart contract vault on Island Ethereum. Then, some kind of messenger sails over to the destination island and says, hey, I saw them lock up the ETH. It's legit. And based only on that message, the destination island prints a brand new token, a wrapped ETH, which is basically just an IOU for your original.
And this, right here, is the critical point of failure. The entire security of your money, that freshly minted, wrapped ETH, depends completely on the honesty and the security of that messenger in step 2. The destination chain is flying blind. It has to take the messenger's word for it. And well, this is where things tend to go very, very wrong. For years, the whole industry has been stuck in this dilemma, forced to pick between two really flawed ways of building these messengers. You're basically choosing between two pretty bad options. So on one hand, you've got option A. You trust humans. This is called a multi-sig. Basically, a small group of people has to sign off on every transaction. It's super fast, it's cheap, but if those people get hacked, or if they decide to go rogue, your money's gone. On the other hand, there's option B. You trust math. A piece of code called a light client verifies the source chain's cryptography directly. This is way, way more secure. But forcing a blockchain to do all that complicated math is incredibly slow and wildly expensive. So expensive, in fact, that it's often totally impractical. And let's be clear, the trust humans model has failed spectacularly. The Ronin bridge hack is the poster child for this. Hackers got control of enough of the validator keys, the human messengers, and just signed off on a withdrawal of over $600 million. It's a brutal, catastrophic example of what happens when you put your trust in a small, centralized committee.
And all of this boils down to something known as the bridging trilemma. The idea is simple. You can pick any two of these three things: security, low cost, or speed. You want it fast and cheap? You're going to sacrifice security. You want it secure and fast? Well, it's going to cost a fortune. For the longest time, getting all three just seemed impossible.
But what if there was a third way? A completely new kind of messenger that could actually break the trilemma. And this is where a really cool technology from Oasis called ROFL, which stands for Runtime Off-Chain Logic, steps onto the scene. Okay, stick with me here. Imagine your messenger isn't a group of people who can be hacked. Instead, what if it was a robot? And this robot lives inside a completely secure, unbreakable box. The hardware itself guarantees that nobody, not the owner of the server, not a hacker, nobody can mess with the code it's running or see the secrets inside. This secure little box is called a Trusted Execution Environment, or a TEE. And that is exactly what ROFL is. It takes that super secure trust math model, the light client, but instead of running all that expensive computation on-chain, it runs it off-chain, inside that secure TEE black box. So the TEE does all the heavy lifting and then just sends a tiny, cheap, verifiable message back to the blockchain that basically says, hey, I did the math, it checks out. And you can trust me because my hardware is literally tamper-proof.
And the difference here is just staggering. Look at this. Trying to verify a transaction with a traditional light client on-chain could cost you $100, maybe more. With ROFL, you get the exact same mathematical, top-tier security, but the cost on-chain drops to less than a single penny. This is a total game changer.
So let's just recap. The old multi-sig model? Fast and cheap, but you had to trust humans. Not great. The on-chain light client? Super secure, but painfully slow and expensive. Oasis ROFL? Well, it gives you the best of everything. You get the hardcore mathematical security of a light client with the speed and the low cost of a multisig. It totally breaks the trilemma by shifting the trust from fallible humans to verifiable hardware.
But here's the thing, this technology is about so much more than just moving tokens around more safely. It actually unlocks a completely new vision for what's possible when all these blockchains can finally work together.
See, because ROFO can handle complex logic and private data inside that secure TEE, you can create something called cross-chain intents. You're not just saying, move my money from A to B. You're giving it complex, conditional instructions, like you can tell it to move your funds, monitor a market on another chain, and only execute a trade under specific conditions, all while keeping your entire strategy secret from the public until the very last second.
And what's the endgame for all of this? It's a concept called chain abstraction. This is basically the holy grail of interoperability. It means the user experience gets so smooth, so seamless, that you can use an app on any blockchain you want without ever thinking about what network you're on, or what a bridge is, or what a wrapped asset is. All that complexity just melts away into the background.
So I'll just leave you with this question to think about. What does the world of crypto look like when all these islands are finally connected, not by rickety, vulnerable bridges, but by secure, invisible superhighways? What really becomes possible when the borders between blockchains just disappear?